we're told each of these black lines represents some fencing where this length is x, which means so is this, and so is this, and the distance from S to R is y, so the distance from P to Q is also going to be y. And it tells you that the total length of the fencing is 120 meters. So if we look at the lengths, you've got y plus y, well that's 2y, plus, and then you've got 3 x's, so 2y plus 3x is equal to 120, which is the length of the fence. Now we need to rearrange that to make y the subject, so I'm going to subtract 3x to start with. So 2y, so taking away 3x from this side, I'm left with 2y. This side becomes 120 minus 3x. And if I then divide both sides by 2, this side becomes y, and this side becomes 60 minus 1.5x. Okay, moving on, we've got to the area of the enclosure PQRS is A. Now the area of the whole thing, the area is going to be the length times the width, which is going to be x times y. But if we look, what we're asked for here is to find an expression for A in terms of x only. So what I'm going to do is I'm going to replace the y here with 60 minus 1.5x. So A is going to be x multiplied by y, which is this 60 minus 1.5x, and that's the same as 60x minus 1.5x squared. So A is equal to 60x minus 1.5x squared. The question now asks me to differentiate, so to find dA by dx, so I'm differentiating with respect to x. If I differentiate 60x, I just get 60 minus, and now to differentiate this, I'm going to do 2 times 1.5, well that's 3, and I write x, and then the power goes down by 1 to just 1. So it's just 60 minus 3x. Remember, when you're differentiating, if y equals ax to the power n, then dy by dx is going to equal a times n, so a n x to the n minus 1. The question then says find the maximum value of a. Now to find the maximum from a graph and to find the maximum we differentiate, well that's just dA by dx, and we put the differentiated expression equal to 0. So that means that 60 minus 3x is equal to 0. Adding 3x to both sides, 60 is equal to 3x, so x dividing both sides by 3, x is going to be 60 divided by 3, so x is equal to 20. So for the maximum possible area, x is equal to 20. So this will be 20, and this will be 20, and this will be 20. So x is 20. The y then, well, y is going to equal 60 minus 1.5x. So if x is equal to 20, y is going to be 60 take away 1.5 times 20, which is going to be 60 take away 30, which is equal to 30. So for the maximum area, x is 20, y is 30, the area of the rectangle is x times y. X times y then is going to be 20 times 30, which is 600. So the maximum possible area of the enclosure is going to be, so the maximum area is going to be 600 square meters.